Hello guys, welcome to Learning is Fun, and this is a tutorial video on how to solve calculational problems. Here with me are some tips that I've used in the past in exams, in classroom tests, and they've really helped me a lot in solving each calculational question that arose during that period, and I was able to solve them correctly. So these tips are not gotten from any book or any journal, so they are just based on my past knowledge, and I feel each of these tips might come in handy when you want to actually use them in any calculational question, either advanced course, ordinary level course, A level exam, any kind of exam or any test you want to do. It actually covers majorly each of them. And here with me are the tips, and I'll start with the first one, which is to identify the topic of the problem and the main theme involved in the topic. Let's take for instance in an exam or which you have a question to solve, and at first glance you find it difficult to solve it, but once you read the question, and you can understand it clearly, you'll be able to identify the topic from which the question was taken from and be able to progress further ahead and solve it correctly. So let's take for instance whereby we have a word problem and we have to relate it and look at it carefully. We notice that we would get some variables, some unknowns where we have to write down, and this might form an expression, or we use it to form an equation, and we solve it gradually and we get either a simultaneous equation till we get our final answer. So once we can identify the topic of the problem, we will know the next step to take, the main theme involved in that topic, either we to solve it simultaneously, quadratically, or just do simple arithmetic operations and we get our final answer. In some other cases, it might just be a more direct question, just like simplifying or factorizing the question, and that is just straightforward for us to actually get the answer because it tells us what to do. So in most cases whereby our calculational question is not in a more direct form, we actually have to just read the question and actually detect the topic whereby the question was gotten from. So that's that about identifying the topic of the problem. So now the next step is to take notes of the values given. Each questions would have values or parameters given, and this is either what you have to work with to get an answer, and this answer you get, you use it to now work with the values that were given to calculate your final answer. Or in some cases whereby you just use the values that were given to you and you just calculate or work with them and use it to calculate your final answer. So each of these two cases might arise depending on the kind of question that was given to you. So I have some examples with me that actually explains these two scenarios. So let's take a look at them. Students, 30% are boys. Find the numbers of girls. So this example here now, I actually use the values that were given to me first to calculate the total numbers of boys in the classroom, and from there I'll subtract my answer from 50 to determine the numbers of girls in that class. So here I have the total number of students to be 50 students. We have the percentage of boys to be 30%. Why? So for me to determine the numbers of boys in that class, that will be 30 over 100 times the number of students in the class, which is actually 50. So zeros actually cancel out. So what I'm left with here is 15 boys. So that means the total number of boys in the classroom, they are actually 15. So I'll subtract that from 50 to get the numbers of girls in the class. So that will be 50 minus 15, which will actually give me 35 girls. If this was a percentage tutorial video, I actually have explained more on percentages, but right now the total, so we can see that the total percentage is actually 100%, and From here now, since we know that 30% represent boys, the remaining percentage left would be for girls, which is actually 70%. So if we do 70% of the total number of students in the classroom, that would actually give us the numbers of girls. So that would be 70 over 100 times 50. 0 cancel 0, 0 cancel 0. So we're left to 7 times 5, which is actually 35 girls. So we can actually see that in this first example here now, I actually had to use the values we have to calculate a particular answer, and from that answer I now use it to calculate my final answer. So in some cases it might be that you have to solve for a series of answers before you can actually get the final answer that you are told to solve for in the question. So let me now take a more direct question whereby we just use the values given to solve for our final answer. A car travels a distance of 36,000 meters in 1 hour. Calculate the speed of the car. Here, actually, we know from normal mechanics in physics and normal speed formula, we actually know that speed is actually equals to distance traveled divided by the time taken. So from here now, the distance we were given is actually 36,000 meters, and we have our time in 1 hour in hours. But actually, I'm also going to talk about units in the last part of this video, because in some cases we have to actually work with our unit, some standard unit of measurement. Here now we have it in hours, but we have our distance in meters. If it's that we had our distance in kilometers, I would have worked directly with this, but here now I need to convert these hours to seconds, and if I'm going to convert 1 hour to seconds, that's actually going to give me 3,600 seconds. So the distance traveled is actually 36,000 meters, and 1 hour is equivalent to 3,600 seconds. So the zeros actually cancel out, so I'm left with 36, and when I divide that, it actually gives me 10. So I'll actually have it to be 10 meters per second. So that's how you solve your question, because your question might be in either of these two forms: a direct one whereby you already know what to do and you just work directly with the values given to solve for your final answer. In some other cases, it might just be that you have to use the values given to calculate an answer, and when you get that answer, you use that answer to solve for your final question, solve the final question. So here now, the next one is to So I have that. The next one here is to take into consideration any theory or explanation related to the topic. Here now, if you take for instance a physics related problem that involves motion of an object being thrown vertically upwards, theory tells us that acceleration due to gravity has to take or have a negative sign. That is, it has to have minus 10 meters per second squared if you're to input that value to your formula of any formula that is related to a free falling object. So, and the fact is because motion is not occurring in the direction of gravitational force, which always act downward. So in that kind of scenario now, what would actually happen is that the value of g, which is always our acceleration due to gravity, would actually be negative, which will be minus 10 meters per second squared. So if you're going to do any problem related to that, so you have to take into consideration any theory or explanation related to the topic, unless if you don't use this negative values of acceleration due to gravity because you're going in an upward direction vertically, you're going to get the wrong answer. So in any course or any field, there must be a theory related to a calculational question. So, and if some cases, if there's no theory related to it, that's when you just go directly to the formula, and that's what I'm going to explain next. So you have to take into consideration, maybe either in business maths, in O-level mathematics, any topic, engineering course, there might be a theory included to the problem or calculational question. So you have to therefore take into consideration any theory or explanation related to the topic. So now that's that about the theory. So now recalling the formula, in some cases whereby you don't need to have any theory or any background knowledge of any law, you just go straight and use the formula. In some cases like that, you might just have an example of maybe e.g. areas of shapes. So here now you just use the formula. For example, the formula of a rectangle for the area, to calculate the area, is actually equals to the length multiplied by the breadth. So here now you can just work with your values given and you just get your final answer straight ahead. So this is just another scenario whereby you don't have any theory, whereby you just have to remember the formula of that calculational problem and you just take it into action and solve for your answer. So now that's that about recalling the formula. So now let us now look at the use of some background knowledge or topics. Here now, in some cases, you might need to solve your question and it might lead to maybe you drawing a triangle, right angle triangle. And when you have a right angle triangle, what you're to consider now in that case is to consider the use of Pythagoras theorem. So let me draw out my triangle here. So if I'm to draw it out now, so you can have something like this. Sorry, let me just sketch it out. Let me erase this. So you might have something like this, a right angle triangle. So whereby you have your longest side, hypotenuse, and the other two sides, one representing either your opposite and the other one representing your adjacent. So when you have something like this, a question related to you drawing, when you have a question related to you drawing a right angle triangle, so what you have to put at the back of your mind is Pythagoras theorem. You have to use this to be able to solve that question. If your problem links you to this diagram, you have to make sure that to calculate the length of any side of this triangle, you need to know Pythagoras theorem, and that would be the square root of the hypotenuse equals to the square of the sum of the other two sides. So that's just Pythagoras theorem. You have that Pythagoras theorem. So once you have this, you can, if you don't have this background knowledge, also some other background knowledge on conversion of one unit to another unit, like centimeter to meter, millimeters to meter, also talking about mass or weight. So you have to know all this little background knowledge. Also in some cases, maybe trigonometric identities and some other formulas which you have to know. If you don't know them, you might not be able to solve your calculational question. So you have to just take note of that. So now in this form now goes majorly to maybe like some business maths problem, some physics question, whereby you have your question or your problem and you can't really solve it unless you have to interpret it in another form. Either you're to plot a graph and therefore now determine the gradient to be able to solve your calculational question, or some cases like physics whereby you have topics like moment of a force, whereby you have to draw out a kind of meter rule, you have a support of the meter rule, then you have some masses on it, and you now have to determine the new equilibrium point whereby this mass have to balance. So you have to just picture it out, you have to draw it, interpret the problem in other forms so that you can be able to easily solve it. So you have to have this at the tip back of your mind and at your fingertips to know that, okay, now if you have a problem like this, once you've identified the topic, you know that you have to be able to interpret it to other forms that grammatically, so that you can be able to solve it correctly, to know how you get your final answer. So now that's that about interpretations of the problems in other form. Now working with parameters and order of operation, here now we'll just be talking about board mass and bead mass, where board mass represents bracket or of, division, multiplication, addition and subtraction, whereby all the same letters in board mass have the same meaning except for the I, letter I, which represent indices. So this just shows us our order of operation, whereby you have to execute anything that is inside the bracket first before you continue your arithmetic operation, and followed by of, which actually changes to multiplication and other order of operation like that. So you have to just take notes of all these things, unless if you don't follow your order of operation, you're actually going to get a wrong answer. So now that's that about working with parameters. Now the last part is the associated unit of quantity. Here now, like the speed example I worked with earlier on, I had to convert the hours to seconds because I had to use the unit to solve for the value of speed, because I know that speed have some standard unit of measurement, which are kilometer per hours, or we have meter per seconds, either case. So you actually have to use the associated unit of quantity. In some other cases like calculational subjects in business maths, economics, engineering, mathematics, you might have different kind of units. So you have to make sure that you are strict with the unit of the quantity you're actually solving for. In terms of money, you might have dollars, you might have seconds, meter, you can have so many things, newtons, and so other types of units, whereby you have to just try and work with them so that you can be able to solve for your answer correctly and accurately. So that's all about how to solve calculational problem. So if you have any comment or suggestion, you can just kindly drop them below, and if you like this video, you can click the like button and subscribe. So thank you for viewing.